Hi, in this video we're going to be graphing in Vertex form. So you're going to be given an equation, a function, that is in this certain form where we have parentheses and a squared and then probably something outside as well. So the first thing we're going to do based on what we know about transformations is we're going to take this and we're going to describe the transformation. So if we describe this transformation, this positive 1 in here tells us that we're going to move it left 1. And this negative 2 tells us it's going to be moved down 2. Now, if you want more information on that, posted a video previously about describing transformations specifically. Check that out if you need that. Based on that, this is really telling us that from our parent function, from y equals x squared, which has a vertex at 0, 0 at the origin, we're going to take that vertex and we're going to transform it according to our left and right movements and our up and down movements. So we're going to take that and we're going to move it left 1 and we're going to move it down 2. So now our vertex is located at negative 1, negative 2. Now once we find the vertex, we always have to find that vertex. We're going to find points around it, but we're going to use what we know about this. So here's the vertex. We know that the axis of symmetry is an imaginary line that cuts the parabola in half. It's a line of symmetry, and it goes through the vertex. So that's at x equals negative 1. Looking at this, we also need points around this. So I'm going to fill in my table negative 1, negative 2, but then I also need points around this, and I can also use the symmetry to reflect these points. So an x value that's really close to negative 1 is 0. Another one would be positive 1. And so I'm just going to take these values, and within my function, I'm just going to fill in like f of 0 and see what happens. When I do this and I simplify this down, so either using the calculator to type out what I have, or simplifying it down, I get 1 squared and it's negative, and so I end up with negative 3. So f of 0 is negative 3. And if I take that and I substitute 1 in, I get 1 plus 1, which is 2. 2 squared is 4, so it's negative 4 minus 2, which is negative 6. So f of 1 is negative 6. So I'm just going to take these and I'm going to plot them really fast. 0, negative 3, 1, negative 6. Now, what I can also do is I can also use this line of symmetry to find other points. So if I reflect it across, I have a point at, what, negative 2, negative 3. And then if I take this point that is 2 away, then I have this point that is at negative 3 and negative 6. So now I have plenty of points, and I can draw my function in. Looking at this, the vertex is the highest point, so it is the maximum. If we're looking for x-intercepts, not applicable. We don't have them, or we could write none. The y-intercept, we just happen to find when the x was 0, so 0, negative 3 was our y-intercept. Now, if that doesn't happen to be a point on there, we can always substitute 0 in for x into our function and find that y-intercept. The second example, very, very similar process. We're going to describe the transformation. This negative 4 tells us it is to the right 4. The positive 3 outside tells us it's up 3. So from our origin, we have to the right 4, 1, 2, 3, 4, and then up 3. So we're at 4, 3 for our vertex. If that's our vertex, we know the axis of symmetry goes through it. It is that imaginary line, and it is at x equals 4. So imaginary line through it, here was our vertex, and now we have to find points around it. So I choose x values that are very near that axis of symmetry. Axis of symmetry is at 4. I'm going to choose 3, and I'm going to choose 2, and I'm going to substitute those values in, simplify it down, and find the y values that go with it. So when 3 goes in, I get 5. When 2 goes in, I get, simplified down, 4, 8, 11. So I have 3, 5. I could use those to reflect across. I would also have 5, 5. That point would be right here. And then if I reflected that across, I would have 6 and 11 as well, way up here. Taking this and now drawing my function. This is the lowest value. The vertex is the lowest, so it is going to be a minimum, lowest, smallest. The x-intercept. This one again does not have x-intercepts. It does not hit the x-axis. If it did, we would list those. So we're going to write none. Sometimes they will have one solution or two solutions. They'll hit the x-axis one or two times. This one has none. The y-intercept. The y-intercept is always when x is 0. So we have to substitute 0 in for x within our function to see what happens and to find that value. When I do that, I get 0, I get 16 times 2 is 32 plus 3 is 35. So although it goes way off the graph, we still write it as the y-intercept of 0, 35. So as a quick recap, our strategies, we're going to describe the transformation. We are going to locate the vertex from that description of the transformation. So left, right, up, down. That's going to be our vertex. We know that through our vertex goes an axis of symmetry. And that axis of symmetry, if we find values on our function around it, we can reflect it and find other values. So the big things, we need a vertex and we need points around it in order to graph it. Thanks for joining me. This was, again, solving and graphing in Vertex.